In this lesson, we'll learn about what a correlation is and also ways to explain correlations. So a correlation between event A and event B just means that there is a regular relationship between A and B. For instance, in the frog deformity case that we've studied, we learned of that observational study where researchers went out to several ponds in a nearby location, and they measured pesticide levels in the ponds, they measured parasite presence in the ponds, and the deformities in frogs that were living in the ponds. Now let's imagine then there were frogs all over in all of these ponds. What they found then was a correlation between parasites and frog deformities, but they found no correlation between pesticides and frog deformities. In this diagram, we can see why that is, because if you take a look at these four ponds here, in each of these four ponds, there is both the presence of parasite and high frog deformities. In other words, the two things are happening together, right? There's a regular relationship between parasites and deformities. Where there are no parasites, there is not a high level of deformity. So there is a correlation, a regular relationship between parasites and deformities. Notice, though, there's no correlation between pesticides and frog deformities because there are no pesticides in any of the ponds. Yet there are lots of deformities here in this pond, but not in this pond. There's no pesticides here, yet there are deformities, no pesticides here, and no deformities. So that is not a regular relationship between pesticides and frog deformities. So this type of result indicates a correlation between parasites and frog deformities, and no correlation between pesticides and frog deformities. Now, whenever somebody tells you that two things are correlated, like parasites and deformities, we're going to now introduce three possible ways to explain that correlation. Why is this regular relationship being found in these ponds? Here are the three that we'll study. It could be that factor A is causing factor B. Maybe A we'll think of as the parasites and B is the deformities. Or it could be that B is causing A. Or it could be some third factor, we'll just call it C, is causing both A and B. So if we think about this, what might seem most reasonable to you is that, well, the parasites might be causing the deformities, right? But that's only one possible explanation for a correlation. It could be that somehow frogs with deformities are somehow causing parasites to appear in greater numbers in those ponds. Or it could be some third factor is causing both the appearance of parasites and deformities, yet the two are not related, right? So a correlation just means that two things show a regular relationship, but it doesn't tell us what's causing what. Of course, the task of science is to figure out what's causing what in the world. Okay, so to get some practice explaining correlations, let's take a look at a couple more examples. The first example will involve storks and people, and you may have heard your parents or somebody else talking about how parents sometimes tell a story to little kids about where babies come from, and it involves storks somehow grabbing babies from who knows where and delivering them to the happy parents. Now, that type of story might be one possible explanation for a certain correlation found in nature. There are places around the world where the following pattern holds true. In region A, someplace in the world, like some northern European countries, there are places where there are very few storks and very few humans. Yet in other regions around the world, there are many storks and many humans. Now that's a correlation, a regular relationship between storks and humans in these different locations. Well, the old story that storks bring people, right, deliver babies to families, would be one way to explain that correlation. Right, so where there are many humans, they're wanting to enlarge their family. Well, you need a lot of storks to carry the babies, right, to those families. Where there are very few humans, you don't need as many storks doing delivery duty, right? So the story of storks, factor A, causing people, factor B, A causing B, would be one way to explain this correlation. But there are others, and so it's instructive to think about different possible explanations for a correlation, and this will help us practice some thinking skills. So let's take a look at some other possibilities. It could be that this first one here, people are breeding storks. So in regions where there are a lot of people, those folks might be setting up stork breeding operations. So you're going to have a lot of storks. Maybe they eat the storks, for example. So they breed them and eat them. But even so, the idea then is in places where there are more people, there's going to be more storks because people are breeding storks. We could call that an example of B causing A if we're defining the people as the B factor and storks as the A factor. Another possibility would be that the environment in region B is simply better for storks and people, better than region A. And so in this case, it would be a third factor. The environment is causing both storks and people to show up in high numbers in region B and to not show up in high numbers in region A. So here we have some environmental factors. Maybe there's good water, good climate, etc., food sources for both people and storks.
It's 4
and that's
hours.
why you find the correlation. Whereas in region A, right, the habitat is not suitable for storks or people. Could be number 3 here, storks feed on human trash. So maybe the storks make use of our waste. And so where there are lots of people producing waste, there's going to be lots of storks, lots of food to support larger stork populations. And so again, where there are very few people, not so much trash, and maybe the storks don't have enough food, and so they can't maintain as high a population. So again, the explanation for the correlation here, we're going to call this one a B causing A again, right? Because it's something humans are doing that's causing the level of storks in region A or B. And the fourth one here, people take pictures of storks. So here we might think of this one as A causing B because the storks are, in a sense, attracting the people. The people are following the storks. So the storks are causing people to show up. Here they are taking pictures. So in regions where there's lots of storks, lots of people will go to those regions. Where there are few storks, few people go to those regions. So in summary, for the stork case, again, if storks and people are correlated, by the way, it also means that people and storks are correlated. The correlation goes both ways. There are 3 ways to explain that correlation. To explain is to give the cause of something. So we can say A causes B, B causes A, or C causes A and B. Now let's take a look at another example. A researcher goes to a K-12 school and records the reading level and shoe size of every student in the school. The researcher found that the reading ability of students is strongly correlated with shoe size. The larger the shoe size, the stronger the reading skills. Now, I'm going to show you a graph of that and then give you an opportunity to maybe think about what would explain that correlation. So this is what the graph might look like. Here we see on the x-axis foot size, and then on the y-axis reading level. And each of the black dots here would be a single student with two data points for that single student. The researchers measured their foot size and the reading level. So for example, this individual here, to find out their foot size, you go vertically, you drop down vertically to the x-axis, and they would have a foot size here. And then horizontally over to the y-axis, that would be their reading level. Now notice the pattern of the dots kind of makes a line. And so we've drawn a line kind of showing the general trend of the dots. We call that the best fit line for the data. Notice the line doesn't go through all the data points, but it captures the trend of the data points. And this linear relationship here establishes that there is, in fact, a regular relationship between foot size and reading level. There is a correlation. Now let's take a moment to learn how to read these graphs. Here's one way to sort of read a graph like this. You take your finger, right, and if you had this graph on a piece of paper in front of you, and you go ahead at the origin here. So you move your finger along the x-axis while reading what's happening to this factor, foot size. So we say, as foot size increases, right, then you hop up to the data, go back to the low foot size, right, and go up to where the data starts here, and then follow the line, right, as you read what's happening to this variable. So as foot size increases, now I hop up to the data, reading level also increases, right? So you first kind of just describe, so to describe this data, you move your finger along here and say, as this factor changes, and then move along the data while saying how this factor changes. As foot size increases, reading level increases. So that's a correlation. So at this point, you might want to just pause and just try to figure out what would explain that correlation. There really is a correlation between foot size and reading level. Kids with big feet have high reading scores. Kids with little feet have low reading scores. What explains that relationship? So go ahead and pause the video, see if you can answer that, and then we'll pick it up. Okay, so probably right off the bat you eliminated the possibility that foot size was somehow causing reading level. And it might be weird to think how somehow your reading level was causing your feet to grow. So I'm guessing you probably settled on that third possibility, that some other factor is causing both of these to change in a systematic way. And that other factor would be development, right? The aging, the growth of the person, their feet are getting bigger, but all the while they're going to school and they're learning how to read and their cognitive skills are improving and so on, right? So a third factor is going to be causing both foot size and reading level to be increasing, and that's why we get this correlation. We can kind of show this here. We would say event C, the development, the growth and development and education of the person is causing the two factors. It's not that foot size is causing reading level or the other way around, but the third factor is causing both. Now let's look at just a couple more graphs here. In this graph here, we see the relationship between daily fat intake, right, and in your diet, and then the y-axis is rates of cancer. And these are different countries around the world. And so again, using our technique of reading graphs, as estimated daily fat intake increases, I hop over to the trend now. They don't have a line here, but there's a clear trend. Rates of cancer increase. Now this is a correlation, a regular relationship between the two. Now, by the way, this is called a positive correlation, because as this factor down here is increasing, the other factor on the y-axis is also increasing. That's called a positive correlation. But we can have a situation of a negative correlation. Consider this one here. Here on the x-axis we have income inequality as found in different countries in the world. Now, inequality is defined as the difference, say, between the wealthy folks in the country and the poor folks, the difference in their income, right? So as income inequality increases around the world, the trust that people have over here, this is a measure of people's trust for others in their society. So it's the percent of people agreeing with the statement, most people can be trusted. As income inequality increases, the levels of trust decrease. Notice what I did. I go over here with my finger. As income inequality increases, then I hop up to where the data starts, except now it starts high, and I go down the trend line while reading what this factor means here. So as income inequality increases, trust decreases. But again, in both of these cases, we see correlations here, but it doesn't tell us what's causing what. So in the case of cancer, it could be fat is causing the cancer, right? But it also could be cancer somehow is causing people to eat high-fat diets, or it could be a third factor is causing both. And likewise here for this correlation, although it's a negative correlation, the three modes of explanation still apply. It could be somehow income inequality is causing levels of trust to change. It could be levels of trust are causing income inequalities to change, or it could be some third factor that is causing both. So in summary, whenever two things are correlated, we have there are more than three, but we've learned about three ways to explain that correlation. A causes B, B causes A, and some third factor is causing both. And to figure out what's really going on between two things that are correlated, you have to investigate further using the method of science.